Let's take a look at this example. Again, we're supposed to eliminate one of the variables. What we're supposed to do first, look at your coefficients. I'm going to look at my y coefficient. I have 9 and I have 3. I'm supposed to eliminate y in this case, for example. So what I can do, I'm going to multiply the second equation by -3. Someone is going to ask why I'm going to multiply by -3. Let's take a look. Copy down the first equation. We have 12x plus 9y equals -14. Multiply the second equation by -3, as I said. 4 times -3 gives me -12x. Positive 3 times -3 gives me -9y equals -3 times -3 gives me +9. And let's take a look what we'll have over here. Now we can perform the addition because the coefficients, don't look at the signs at this moment, next to x are the same and they have different signs, and also, as you noticed, the coefficients next to y are the same and the signs are different too. That's why we're supposed to perform addition. Okay, remember we add two equations when we have different signs next to the coefficients, or we perform subtraction when we have the same signs. In this case, we concentrate on y coefficient, but at the same moment we got exactly the same coefficient next to x with different signs. That's why we have to perform addition anyway. So I have 12 plus -12 gives me 0, and I have positive 9 plus -9 gives me 0, and I have equals -14 plus 9 gives me -5. So let's take a look at what we have got. We got the false statement because this is not true. 0 is not equal -5. Anytime you are going to eliminate all variables and you are going to end up with the false statement, it means that the system is inconsistent. It means that the system has no solution. If you are going to graph these two lines, you are going to find out that these lines are parallel. So the solution set for this problem is simply empty set. And this is the solution to my problem.